Alright, what's up guys? Welcome back to a brand new YouTube video, and today we're going to be talking about circuits. Alright, so the first thing we're going to need to know if we're talking about circuits is basically like what a circuit is, right? So a circuit, I've drawn out like a pretty basic one right over here. You've got your positive side right over here, your negative side right over here, and this entire thing is basically our battery. So the current from the battery always flows from the positive side to the negative side. And then you'll have like the current will travel along the wire until it hits some resistance. Now the resistance is whatever's like doing the work in our circuit. For example, like a light bulb, that could be resistance. It's making the light. A heater, that could be the resistance. It's anything that's just like doing the work, that the electricity is powering, that's what the resistance is. Every time we go over resistance, we have like a voltage drop. So let's say that this red color represents the high voltage. Once we hit that resistor, it switches to a lower voltage, so we'll highlight that in blue. And you can think of voltage as like the potential of the electricity to do work. So once you cross the resistance, it just doesn't have the ability to do work anymore because all the energy was spent on the resistance. All right, so now in order to understand these circuits better, we're going to have to become familiar with a couple terms. First one's voltage, and voltage is measured in volts or V. Its symbol is V. The next one is current. Current is measured in amperes or A. Its symbol is I. And finally, resistance. Resistance is measured in ohms, and symbol is R. And ohms are just basically look like this. It's the Greek omega. Okay, so I just threw a bunch of terms at you, but you don't really know what they mean. So in order to understand it better, let's look at an analogy. So let's say we've got like a water pump here, and this is a motor that's pumping the water up into this tube, and then the water is like spinning this gear, or spinning this like rod. Then it's coming back into the motor to get pumped out again. So basically the water is moving into this direction, and you can think of current as the amount of water in this tube. It's the same throughout this tube, right? You can think of resistance as this wheel that's spinning, and it's taking the energy from the water. And you can think of voltage as the pressure of the water, and the pressure of the water is basically like how much, that basically signifies how much work it's able to do. Alright, now that we have like a rough idea of what circuits are, let's talk about some laws about circuits. The most important one is Ohm's Law. And Ohm's Law states that voltage equals current times resistance. The next thing we're going to have to learn are called circuit rules. The first circuit rule is the junction rule. And the junction rule states that if we have like a junction in a circuit like this, and you've got a current coming down here, I1, and a current coming down here, I2, current coming out of here, I3, current coming out of here, I4. All it states is that I1 plus I2 equals I3 plus I4. That's all the junction rule says. Alright, and this makes sense, because if you've got like some amount of water coming down through here, and some amount of water coming down through here, then the same amount of water has to exit. So that should make, that should be logical. Alright, that's the junction rule. Now let's talk about the loop rule. The loop rule says that if we have a circuit like this, then the voltage of the battery, so we'll call this V battery, has to equal the voltage drop through the resistor. Or basically, the sum of voltages in a closed loop is always 0. And how this works is V battery minus, we'll call this V1, V1 has to equal 0. And the reason this voltage is negative, we're subtracting the voltage, is because the voltage is in the battery. We're going from here. Let me just color this in so it's easier to see. In the battery, we're going from 0 volts here to like whatever the voltage here is here, max voltage. And in the resistor, we're going from a positive voltage to basically 0. So that's why we're subtracting the voltage here. And that entire thing has to add up to 0, basically. So even if we've got like 2 resistors in here, if we've got like a resistor here as well, and we'll call this V2, that means that V battery minus V1 minus V2 has to equal 0. All right? So now that we've learned about the junction rule and the loop rule, let's learn about the... Oh, and the reason it's called the loop rule is because in a circuit, we can have multiple loops. Just like this. So here we can see we have two circuits. Or we have two resistors. We have two resistors, and they're in what we call parallel, since they have, you know, parallel lines that are going parallel from each other. Yeah. Basically, the same thing doesn't apply because we have two loops. We have one loop this way, and we have another loop like this. So if we call this V1, V2, and we call this V battery, the voltage of the battery, then basically we have two different relationships. We have the voltage of the battery minus V1 has to equal 0, and because that's one loop, this is in one loop, and the voltage of the battery minus V2 also has to equal 0. Because the loop rule always applies to these loops. The sum of the voltages in a loop has to add up to 0. Okay, now that we've got loop rule and junction rule down, let's talk about how resistance adds up when circuits are in parallel versus when they're in series. So when you've got resistors in series, just like this, then we basically have the relation. So then we basically see that this is V. This is V, or we'll call this V battery, this is V1, this is V2. So from the loop rule, since these are all in the same loop, as we can see here, they're all in this one loop here. Oh, and one more thing. Current always flows from the positive side to the negative side. So from the loop rule, we have the relationship V battery minus V1 minus V2 has to equal 0. But from Ohm's law, we know that we know that V equals IR. And we know that the current going through both of them is the same. So if we call this resistance R1 and this resistance R2, and we just call the current I, since the current's the same for both of them, we get that the voltage of the battery equals, if we take these two to this side, with some simple algebra, we get IR1 plus IR2. Right? Just using Ohm's law and moving these two to that side. All right, now we can basically just take the current common, and we have R1 plus R2. So we can see here that when we have resistors in parallel, the resistance adds up, and that'll give you the total resistance. Because basically we can see here that the voltage of the battery also equals I times the total resistance of the circuit, IR total. And this equals I R1 plus R2. So then the I's cancel, and we get that R total equals R1 plus R2. So when you have resistors in parallel, they add up this way to give you the total resistance. Now, or when you have resistors in series, when you have resistors in series, that's how it is. Now when you have resistors in parallel, which looks like this, now we don't have the same current coming down here. Because you can think about it, the same amount of water can't come down here, but the pressure of the water is going to be the same. So this is going to be red, this is going to be red, this is going to be red, and we'll have blue down here. Just like that. The voltage drop is going to be the same because the water pressure is the same, but the amount of water going through these isn't the same. So what relationship can we derive from here? We understand that from the junction rule, we have that the total current has to equal, if we have I1 coming down here and we have I2 coming down here, like this, then the total current, which is basically like the current flowing through here, through the battery basically, has to equal I1 plus I2. just because of the junction rule. Just because the amount of current that is coming out has to be equal to the current that you're putting in. Now we'll use Ohm's law again. V equals IR, and by rearranging, this means that I equals V over R, just by rearranging the formula a little. And we get that V over R total equals V over R1 plus V over R2. Because in this case, the voltage going across all of them is the same. In this case, up here, the voltage going across all of them isn't the same. We have a higher voltage here. We have like a voltage in the middle kind of here, and then the low voltage the rest of the way around, just like that. So the voltage across all of them isn't the same, but here it is. The voltages are the same because you can see that it goes from red to blue, so that means the voltage drop is the same. So we can cancel out, oh, wrong color. We can cancel out all the V's, and we get 1 over R total equals 1 over R1 plus 1 over R2. So when resistors are in parallel, the inverses, or the reciprocals of the resistors equals the reciprocal of the total resistance. Alright, now we should have all the knowledge we need to solve some circuit problems. So now let's target some actual, example problems. Alright, first problem. What is the total resistance of two 5,000 ohm resistors in series and in one parallel and in parallel to one 5,000 ohm resistor? Okay, first let's draw it out. So we have two resistors in series. It's gonna look like this, something like that. Let me zoom out a little. We have two resistors in series, and we have one resistor in parallel to those two, and we've got our battery like this. Let's just hook it all up. So it's gonna look something like this. This one is 5,000, and this one is 5,000, and this one is 5,000. Okay, so whenever we have these types of problems where you're trying to find the total resistance in a circuit, what you're going to want to do is start with like the innermost resistance and work your way out. So here the innermost resistance is going to be these two resistors in series. So how do we find the total resistance in series? It's just R1 plus R2, which we derived up there. So here R1 is 5,000 and R2 is 5,000. So our total is basically going to equal 5,000 plus 5,000. And that basically equals 10,000. So now we can pretend that this entire thing, let's just erase all of it. Now we can just pretend that this entire thing is one resistor with a resistance of 10,000. Alright, because we found that the total resistance of those two was 10,000. Now we have two resistors that are in parallel. Alright, and one has a resistance of 10,000 and the other one has a resistance of 5,000. So how do we find the resistance of the total resistance of two resistors that are in parallel? Well, we know that 1 over R total equals 1 over R1 plus 1 over R2. And here we know that that R1 is 10,000 and R2 is 5,000. So this implies that 1 over R total equals 1 over 10,000 plus 1 over 5,000. So this basically equals 1 over 10,000. And we can multiply the top and bottom of the 5,000 by 2 to get 2 over 10,000. Just so that we have the same denominator, and now we can add these together. So this equals 3 over 10,000. But that's not the final answer, because this was 1 over R total. So to find R total, we have to flip this over. This implies that R total equals 10,000 over 3 ohms. And this is the total resistance of, and this is the total resistance of this circuit right here. All right. Our second practice problem. Let's say we have a circuit that's something like this. Okay, and we've got 20 ohms here, 30 ohms here, and 50 ohms here. Okay, and we've got 125 volts going through the battery. Now, whenever you're starting off with these kinds of problems, it's helpful to just draw on the voltage drops, so that you can get like a rough idea. So that you can get a rough idea of like the voltage drops and where the voltage is changing. And we'll make this one yellow, and we'll make the last one blue. Okay, so let's find, for this circuit, let's find the total resistance, the total current, and the total current through the battery, the current through each resistor, and finally the voltage drop across each resistor. Okay, so the total resistance is just going to be, since all of these resistors are in series, it's just going to be all of them added up together. So that's just 20 plus 30 plus 50, which equals 100. So the total resistance is 100 ohms. All right, now how do we find the amps? Well, we can use Ohm's law. We know that we have a total of 100. We have a total resistance of 100 ohms, and we have 125 volts. Whenever you have the resistance, whenever you have like two of the numbers in Ohm's law, you can always find the third. So we've got 125 volts, and that equals the current times 100, because that's our resistance from right here. So this implies that the current basically equals 125 over 100, which equals 5 over 4 amps. Now let's find the current through each resistor. Always remember, whenever you have resistors in series, the current is going to be the same through them, but the voltage is going to be different. And when you've got resistors in parallel, that was a bad resistor. Let me try that again. When you've got resistors in parallel like this, the voltage is going to be the same through all of them, but the current through all of them is going to be different. That's an important relation to keep in mind. So since the current through all of these is going to be the same, we can just use Ohm's law again, and it's going to be current times resistance for all of these. So current is, so for this one, for example, the current is going to be 5 over 4 times the resistance. Or, yeah, it's Ohm's law, so V equals IR. So it's going to be, 5 over 4 times 50. So this equals 62.5 volts. And now, why don't I let you guys work through the other ones here and see if you can get the current, or see if you can get the voltage drops across these ones as well. Okay, hopefully you paused the video and you got those down. It's just going to be 5 over 4 times the other resistances, which is going to be 30 and 20. So times 30, that just equals 37.5 volts. And then it's going to be 5 over 4 times 20. So this equals 25 volts. All right, and that's the resistance, that's the voltage drop going down each of these resistors. Now let's do the same thing for this circuit, where we've got 20 ohms here, 125 volts going through here, 100 ohms here, and 50 ohms here. All right, first thing, let's find the total resistance. So the total resistance, since these series are in parallel, we're going to add up the inverses. So that's 1 over 20 plus 1 over 100. Oh, whoops, that's 1,000. Plus 1 over 50. and it's just going to be 1 over that. Or let me rewrite this. To find the total resistance, it's going to be 1 over 20 plus 1 over 100 plus 1 over 50. All right, and that equals 12.5 ohms. So that's the total resistance. Step number 2 is to find the current through each battery. So the current, again, is going to be, we're going to use Ohm's Law for this. V equals IR. So since these things are in parallel, since these resistors are in parallel, we know that the voltage drop across all of them is going to be the same. It's just going to be 125 for all of them. So that means 125 equals, and then we have the resistance. So for this one, for example, the resistance is 50, so that's I times 50. So this implies that I equals 125 over 50, or 6.25. Or no, sorry, 2.5. Yeah, sorry. Alright, so I'll let you guys try to figure out the other ones, just 20 and 100 ohms. Oh, whoops. I was supposed to find the total current going through the battery, but that's first. That's fine. We can do this first. So working through these on your own here, you should have gotten 125 divided by the next one, which is 100. So this equals 1.25. And then you should have gotten I equals 125 over 20. So this equals 6.25. Oh, and units are going to be volts on both of these. All right, now let's find the total current going through this battery. So we know that the total resistance was 12.5. So there's two ways we can do this, actually. Using the junction rule, since we've already found the individual currents, we know that it's... Oh, sorry. Oh my gosh, I messed up. These are not volts. These are amperes. This is the current. That's amps. That's amps, and that's amps. So since we already know that, since we already know all the individual amperes, we should be able to add them up and get the total current. So let's just do that really quick. 2.5 plus 1.25 plus 6.25, and that equals 1.25 plus 6.25 is 6.5, 7.5. 7.5 plus 2.5 is 10. So that's 10 amps. Now let's do it using Ohm's Law. So Ohm's Law is V equals IR, and we know that the total resistance is 12.5. So that means 125, which is our voltage, equals I times 12.5. So this implies that I equals 125 over 12.5, and that equals 10 amps. So you can see we got the same answer no matter how you do it, which means we did it the right way. And what was the last one? The last one was the voltage drop across each resistor. So since all the resistors are going to be the same, since they're all in parallel, it's just going to be the same for each resistor, the same as it is for the battery, and that's 125 voltage drop across each one. And we can draw this out too. We've got 125 volts up here, and we're dropping down to 0 volts down here. Yeah, just like that. And it's important to note that whenever you're measuring voltage across a battery, a common mistake I always make is that I assume that the voltage going across the battery is just the voltage here, up here. But that's not true. The total voltage going across the resistor, one common mistake I always make is I assume that the voltage going across the resistor is just this voltage up here, but that's not true. It's actually the voltage drop going from here to here. So here it's 125 because you're going from 125 to 0, but in some other cases maybe you're going from like 125 to 50, in which case the voltage drop would actually be 75. All right. Now that we've got that done, let's do another problem. This one's on resistance. Whoops, wrong color. So we've got a resistor here like this, going up here, splitting off this way. This one splits off this way. We've got a resistor, 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 resistor this way. These connect back up. Then we have one coming down here, and a resistor like this. This is going to be 3 ohms. This is going to be 3 ohms. Sorry, 3 ohms. This is going to be 10 ohms. This is going to be 15 ohms. This is going to be 6 ohms. This is going to be 8 ohms. And this is going to be 24 ohms. And what we have to find the total resistance. All right. So to find the total resistance, like I said, let's work from the inside to the outside. So the innermost things are basically this parallel circuit and this parallel circuit. So let's just work with this one first. It's just going to be, 1 over 10 plus 1 over 15. Or 1 over 10 plus 1 over 15. And that just equals, let's see here. 30, 3, 2, 5, 5 over 30, 1 over 6, 6, 6. Should be 6. And then we can add that up with this 6 volts, and we should get 12 volts. So the total resistance of this entire thing is 12 volts. Or 12 ohms. 12 ohms, sorry. So that's 12 ohms. The total resistance of that. And then we have this one up here. So this is going to be 1 over 24, 1 over 1 over 24, plus 1 over 8. So that equals 6, and then 6 plus 3 equals 9. So the total resistance through here is 9 ohms. There you go. Now we have a resistance of, so now we have 12 ohms here and 9 ohms here. So, wait. Yeah, we've got, 3 plus 2. Yeah, okay, yeah, looks good. So now we've got 9 ohms here and 12 ohms here. So this should be 1 over 9 plus 1 over 12. The whole thing divided by 1. And this should equal 6.55, just about, ish. And that's the total resistance of these two parallel circuits, of this one and this one. So that's the total resistance of this entire thing right here. Now we have this resistance in, oh, I forgot to mention we have 5 ohms through this one. So now we have the total resistance here, the resistance here, and the resistance here, and all three of these are in series. So now we just add them all up. So that's 6.55 plus. Oh no! Sorry. I messed up. This is not 6.55. This is 5. This is, whoops. This is 5.1429. 5.1429. So then we just add up all of this resistance, and we should get 5.1429 plus 3 plus 5. Because we get, 3 ohms from here, 5 ohms from here. And this equals 13.1429 ohms. 1429 ohms. And that's the total resistance.